in a sense, which is the things in like football are for the choose. So at this point, if we choose a building and everybody don't want the building, that's on you guys. So choose a building, choose the pole, The pole said for a reason, use the pole.
Huh? Maybe I leave door open for Tommy. Oh, but I demand, please.
Hello, guys. Welcome to another class.
Hello, sir.
Hi. So, guess what? Guess what, guys? It's a good thing that holiday was last week, Monday, because I was absolutely sick like a dog for the last 2 weeks, and I'm just kind of recovering out of it. So you might see me sound a little bit more boring than usual, than how I'm usually boring. Yeah, but I am coming around. I think I'm almost there, right? And we have an exciting new topic to move on to today, right? So today we are going to move on to the world of 3D. So far we've been dealing with a lot of 2D 2D software and 2D activities. Now we're going to go into the world of 3D. All right, just let me locate my stuff. Right, here we go. So let's talk about 3D space. Right. So the truth is, I believe it should be easier for us to learn a 3D program more than a 2D program like Photoshop or Illustrator. And one of the reasons I believe that is because we grew up seeing the world in 2D, in 3D. For example, when somebody turns sideways, they don't turn into a paper thin character. Am I right, Elena? That's not how we perceive the world.
Awesome.
Exactly. I know some of us, we want to lose weight until we are maybe paper thin, but still impossible because everything around us has full, we experience in full 3D ever since we've been born. So technically, Photoshop is more foreign to us than SketchUp because when we were using all of those programs, this was our interface. It was a flat piece of paper and we drew on this piece of paper. Now we're going to go into an interface that it is 3 dimensions. But generally, do you know what the catch is?
What's the catch there?
The catch is that we are still experiencing this 3D environment on a 2-dimensional screen. The computer screen that is in front of you is 2-dimensional, but it is showing a 3D scenario. So that is where we have the word viewport that comes on, because viewport is a window into a 3D world, right? Now, if we wanted to if we wanted to fully use a 3D program in 3D, then we would have to get one of those fancy VR goggles where we would actually be in this 3D space, actually moving stuff around. And that would be real 3D. But the vast majority of us are going to be doing 2D and 3D on a 2D screen. Maybe for years to come. Maybe until we get one of those fancy glasses that is able to project everything in 3D. But for now, we're stuck with these computer screens. So we are able to identify depth, shadows, light, texture, and colors, and that is what helps us to perceive that a scene is 3D. So if we should ask ourselves what is 3D, I think this would be the answer.
When we work in 3D software, we digitally represent the natural world, which can be measured along 3 dimensions. We have left and right, up and down, and back and forth. These 3 dimensions are called axes and are usually defined as X, Y, and Z.
So I'm not seeing on screen still.
When we work in 3D software, we digitally represent the natural world, which can be measured along 3 dimensions. We have left and right, up and down, and back and forth. These 3 dimensions are called axes and are usually defined as X, Y, and Z. We use these axes as a way of measuring and navigating our virtual 3D world. These axes can be used to measure the position of objects, the size of objects, or they can measure the distance between objects. Imagine a city with tall buildings. The grid of the city represents 2 of the 3 axes. Any intersection in the city could be described via 2 numbers. For example, we could go to the building at the corner of 3rd and 4th. The floors of this building would be considered the 3rd axis in our 3D world. So a coordinate of 3, 4, 5 could be seen as the 5th floor of the building at the intersection of 3rd and 4th. In a 3D application, this same measurement system is how we manipulate objects. When we move an object in 3D, we think of it as moving in a straight line. But the 3D application itself measures this distance along x, y, and z. Similarly, when we scale objects to make them bigger or smaller, we measure the change in size along x, y, and z. And when we rotate objects, we can measure that rotation as happening along a combination of the x, y, and z axes. As you can see, our natural world can be described using 3 sets of numbers. Understanding this coordinate system is the first step to working in 3D. When we work in a 3D application, we're typically working in what's called a viewport. Now, a viewport is simply a 2D window onto our 3D world. Now, this window can be configured to view our scene in a number of different ways. So, for example, if we want, we can take this scene and view it in what's called wireframe. Now, these wires are basically the geometry of our scene. Now, if we want to go even simpler, we can go into what's called a bounding box mode, which basically just shows broad outlines of the objects in our scene. Now, typically, we want to see the shapes of our objects, so we can also do what's called smooth shading. Now, smooth shading allows us to see the shape of our objects. And if we want, we can also do things such as superimpose our wireframes over our shaded view to give a better sense as to where the detail of our geometry is lying. Now, in addition to this, we can also add color. So if we want, we can add color and texture as well as lighting. Now, some of these features are software dependent, so each application will be a little bit different, but all of the major applications will allow you to see your scene in multiple ways. Now, because we're viewing our 3D scene in a flat 2D window, we will need to navigate. Now, again, every software is a little bit different, but they all have pretty much the same navigation controls. So typically, we'll have something that allows us to orbit or rotate the scene. And in fact, what we're doing here is we're rotating a virtual camera around the scene. Now, if you can picture in your head a camera that's moving, this will give you a better sense as to how to navigate your scene. We can also take our camera and move it around to adjust where it's looking in the scene. And we can also push our camera back and forth. Now, this is called a truck, so we can truck in or truck out. Now, because we're viewing this through a virtual camera, we can do things such as change the angle of view or the focal length of our virtual camera. So we can zoom in and see this very closely, or we can zoom out. And again, we're just changing the focal length of the camera. So this is like having a camera with a zoom lens. Now, in addition to this 3D view or perspective or camera view of the scene, we can also view the scene from a 2D perspective. This is called an orthographic view. Now, for example, if we want to view the scene from the side, we can go into an orthographic view of the side, and this gives a parallel projection. In other words, this is looking at the scene directly from the side where everything is perpendicular and parallel. Now, in addition to this, we can also look at another view, such as a top view. And again, these views give us more specific views on our scene that may allow us to adjust and manipulate the objects in the scene more precisely. But the ultimate goal of this is usually to get into the perspective view and be able to adjust the camera so that we can take a picture of it or render the scene. So when you work in a 3D package, you're going to be manipulating your objects in what are called viewports. Now, these viewports can be configured to have multiple views, and we can also change the angle of view and perspective of our camera. When we work
Yeah, I think you're muted.
Sorry about that. Right. So what I was saying is that um, just like what was said before, this is a viewport. This is in SketchUp. And just like how we can show things in shaded or wireframe, different applications have different ways to show our model. Now, because we are starting from we're coming out of the world of 2D into 3D, we're going to be looking on SketchUp and comparing some of its features to Illustrator. So, Evelyn, do you have your SketchUp ready?
Yes, sir.
Is this answer indicative of the rest of the class? Everybody have their SketchUp ready?
Sir, can the online one? The web?
Kinda. Maybe you can get away with it for today's class, right? Because we are going to do a class activity for today as well. So we have a bit of stuff to go through. We're even going to do some work in this morning session, as well as our exercise 5 in the evening session, right? So we're going to kind of jump into the user interface of SketchUp. And because this is a whole new type of software, I want us to, as much as possible, try and follow along so that you can understand the intricacies of a 3D program. Now, SketchUp is going to be a super important program for you guys going forward, because you're going to use it for the rest, pretty much for the rest of your career. I still use SketchUp every day to present schematic designs to clients, right? So this is where it all starts, guys. Okay, so welcome to exercise 5, and as per usual, if you log on to the DDM site, navigate down to exercise 5, you will see that exercise 5 involves using SketchUp 3D software, and there's also some tips and descriptions of how to use the application that's on the handout. And we are going to do 2 objects today. This first object is not to be submitted, it's just going to be done in the class, and this object here will be the object that will be submitted. Okay, so we're going to use SketchUp. Now there are 2 versions of SketchUp. There is the SketchUp application, which you can load up. When you load it up, you will get a welcome screen like this, and then you will be asked to select a unit. You are going to select the millimeters version, the millimeters unit. Now the next version of SketchUp runs in a browser. Before I show you that, this that you see on screen is the application. To see the browser version, if I bring up a browser, type SketchUp in Google, and you should get the option, well, you just click on the first option that comes up. Then you would go to try SketchUp. And then you will see different versions here. You could go for the free personal projects and just go to start modeling, and then you'll be taken to the web version of SketchUp. Right, and when you go here, then you go to create new, and there you have it. So here we have the web version and the desktop version. So you might notice that they're a little different. These tool icons here are on the side. However, for this exercise, we will be using the desktop version of SketchUp and not the web version. But if you only have the web version, you can follow along. All right, so when you open SketchUp, this is what the basic user interface will look like. You should have some icons towards the top. Then you might notice you might have a character here for scale, and you will notice perhaps a background. In this case, it is a sky. Now, before we get going with SketchUp, I want us to make some quick alterations to the user interface that will make our experience a bit better, right? And this is why we want to use a desktop version. So first, I want us to go to camera. Then I want us to change to parallel projection, like that. Then I want us to go to camera again and go to standard views, then select the top view. Okay, great. Next, we're going to go to view, toolbars, and we are going to turn off the getting started. You'll notice that there is a getting started tab, and that tab is here. And getting started, the getting started toolbar.
Excuse me, sir.
Yeah.
Could you start over again from view? I just finished the camera one. Sorry about that.
Don't worry, I will show you as we go along. For now, just go up to view and go to toolbars to enable these toolbars. All right. What we did was to, on the standard, under camera, we changed it to parallel projection, and we went to top view. That's what we did.
Oh no, sir, I got those. It was the views one I didn't get with the
Right.
toolbars.
Right. So you go to views and then go to toolbars. See, views.
Which ones am I enabling again?
You're enabling the one called large tool set.
Large tool set. Okay, thank you, sir.
Yeah, and we want to turn off the one that says getting started. Refers to this toolbar that you see on top, and basically what it is giving us the, let's just say, a good way to start off using the program. But I don't want us to start with the getting started tab. Instead, I want us to turn that off and enable the large tool set. So we're going to turn off getting started, and then we're going to scroll down and look for large tool set, which you can see here. And when you enable large tool set, you will get this tool set right here, right? And if you notice, if I even turn on the getting started, you might notice some similarities. For example, the eraser tool is also here. And you know, you will see some of these tools, but obviously you will see that the large tool set actually has more tools. So I want us to use the large tool set to get started, and instead of the getting started tool set. All right, there we go. So now that we have that ready, before we start to get going, I want to just compare our experience of using Illustrator, of using SketchUp, to that of Illustrator. Now, if I kind of roll this back here, you will see that I have a side-by-side view with Illustrator. Now, of course, Illustrator has its tool set here, and you can see that SketchUp also has its tool set here as well, right? Now, you might also notice there are a few similarities with some of these tool sets, and I drawn these similarities because we are going to explore the user interface, the core user interface of SketchUp, and we are going to kind of compare that to how we used Illustrator in our past exercise. Now, you don't need Illustrator for this exercise. I am simply just showing this as an example, right? Now, what we're going to try out is we are going to draw our experience with using the pen tool, right? And if you remember from using the pen tool, we were able to draw lines and shapes, and we could be pretty accurate about it. So for example, I have written the letter C here using the pen tool. Now, what I want us to do in SketchUp, firstly, we're going to delete this little, this is the top view of that character that you saw. And to delete it, we're going to use our selection tool. And you might notice that the selection tool is indeed quite similar. There is also a selection tool in Illustrator. So with the selection tool selected, we're going to click this guy here and we're going to delete it. All right. Now, if I wanted to replicate drawing this shape in Illustrator, I would need to grab my pencil tool. And the pencil tool is the basic equivalent of the pen tool in Illustrator. They act and do activities pretty similar. Now, to navigate in SketchUp, we're going to use the mouse wheel to zoom in and out, right? Remember, before we get going, ensure that your view has been set to, your camera has been set to parallel and your standard view has been set to top. You can know this because you will see in the top right hand corner that there is a top icon up there. Now, the mouse wheel will zoom in and out, and holding Shift and the middle mouse button will pan around, right? So zoom with the mouse wheel, hold Shift and middle mouse button to pan around. Now, if you notice at the center of your screen, you have your origin point, which is located here. And this is basically the center of your scene. And you will notice that Illustrator does not quite have that. However, in Illustrator, we do have a finite space working with. If I zoom out here, all the way out, you will see that Illustrator has a finite space. You have to be working within this space here and not go beyond these lines. However, when you're working in a 3D program, a 3D program has a viewport which is essentially an infinite space. So because it's so easy to kind of get lost in this infinite space, it's a good idea to always know where is your center point, your origin. And in our case, we're going to start drawing from the origin. All right, now, so remember our objective. Currently, we're just exploring the user interface. You do not need to open Illustrator, but yet still we are going to replicate this shape in SketchUp using the pencil tool, which is located here. Now, before we get started, just to notice some other things about this user interface. And if for some of us, we might have a tray on our right that is here. Now in this case, my tray is actually minimized, but for some of us, this tray might be looking like would be maximized like that. Now if you have this tray here, what you're going to do is to just unpin it by clicking this little pin here, and then it should be able to just roll up like that. Additionally, you also have your menus up top, and you have a little area to display length at the bottom, and some tool tips that is located here. Now to get going, what we're going to do is we're going to click on the line tool using and this is basically our pencil tool, and this works very similar to the pen tool. We're going to start, let's start from our center point, and we're going to draw a line up. As a matter of fact, let's not start from the center point. Let's start from just any random location, and we're going to sketch this out. Now notice that I don't have to hold shift to get a straight line. The SketchUp will automatically snap when the line is parallel. So I'm going to draw the first line here, then I'm going to go across here, and it will do the same thing. Now notice the colors of these lines. Whenever I draw horizontal and it snapped to a horizontal, it gives me a red. Whenever I snap to a vertical line, it gives me a green. Same again, red. So this is how you know, like, when you are at a full 90 degree, because if I was not, the line would be black. Additionally, notice how these snap points might come up when you try to draw. So it's kind of like Illustrator, where it's helping you to be accurate, right? And it also gives you a bit of what you call polar snapping, because you can see these dash lines. If you try to hover at a point, don't click, just hover over it and move. You will see it giving you this dash line that you can use as a kind of reference to know if the line is actually straight. So that is pretty cool. Alright, so I want to stop just short of here like that. Then go, see, I can see that it is aligned to this point because I've gotten my reference line here. Then I'm going to go up, and I can see that this snaps to here. So I'm going to click again and click again to complete. And when I do that, notice that it is a rough shape. Now this is a freehand kind of drawing, digitally drawing, but that's fine because that's what we want to do now, right? So that is pretty interesting. Now just like before, how we drew this this shape here, but pretty much we are kind of stuck on this flat axis. Now what I want us to do now is to transition the shape that we have just drawn into 3D, and to do that you're going to hold the middle mouse button, and you're going to kind of push against, click and hold. You will see the cursor change to a kind of orbit, and you're going to push or pull the mouse while holding the middle mouse button, and that will give you the ability to orbit. So I want us to try and orbit like this. Now right away you notice a difference here, because what we have over here, we can only draw with on a flat piece of paper, whereas here now it is a full three-dimensional space. So because it is a three-dimensional space, what I want us to do now is we are gonna draw on the z-axis. Now pretty much we have been drawing on the x and y-axis, and our y-axis would be like this, and our x-axis would be going this way. But our z-axis is now going perpendicular up this way. So we are now going to draw along the z-axis now, and that will give us the ability to draw in a full 3D shape. Now, in order to do this now, you have to use the orbit tool a lot so that you can know what direction you're going, because things can tend to get a little bit confusing when trying to go in 3D. So what we're going to do, we're going to full screen this because we have left 2D behind, and now we're able to draw in the third dimension. So let us continue here, and this time what I want us to do is we're going to draw this line vertically up. Now notice how I'm getting this color line now, this kind of bluish purple line now. But if I continued on the x-axis, I would have gotten the green line, and if I this is the y-axis, sorry, I would have gotten the green line, and along the x-axis I would have gotten the red line. So that is how you keep track of how you are drawing, as things can tend to look a bit confusing in 3D. For example, if I'm going this way, what direction am I really going? I don't really know, because the line is black. It might just be my view angle that's making it look all weird. But when it snaps to a color, you know that, okay, I'm definitely going along this flat axis now. Or a red color, you know that, okay, I'm definitely going along this axis now. And of course the purple color, or the blue color rather, I definitely know I'm going upward on this axis now. So I want us to use these color axis highlights to help us to create this shape. So what we're going to do now, we're going to now try to angle our shape in a way so we can go up on the Z axis. Let's kind of do it like that. Now, it doesn't matter how tall you make this. The key thing is to make sure that you are on the Z axis. So we're going to do that. Then we're going to come across along the Y axis, and what I want you to do while you're drawing this is to use the middle mouse button to just kind of hover so that you can have an idea of what axis you're drawing in. Now I want it to line up with here, so what I'm going to do is just hover at that point and just slowly move my mouse up, and you will notice that it is giving me this line here that will help me to be aligned with this point. Alright, so I'm going to go there, and then I'm going to attach it here. Now once I do that, notice that this also gets a fill color as well, and if I orbit around, you can see that I've clearly drew a 90-degree angle here. Alright, so we're going to continue with this shape to just get it done. So we're going to go like this, and we're going to do that same thing again. We're going to hover at this point and slowly push the mouse up, and you will see where it will mark that out for us. And we're going to do the same here. Kind of hover from this point. There we go. And we're going to do the same here. Now hover from this point here. If it doesn't work the first time, you have to just kind of go slow with it. Now this might be a bit tricky, because notice that this line is aligned with here. So what, in cases like this, you want to change your view slightly so that you don't have two lines overlapping over each other, and things will tend to get more confusing that way. Then we're going to continue down here. Let's go slow. And down here. And across here. And we're going to go up again. Like that. And then we're going to close this. Now watch what happens when I close this shape. Notice that the entire shape closes. And when it closes, this simply means that, well, everything is correct. And now we have drawn this shape fully in 3D. So great. So now that we have gotten the hang of this, we were able to draw this shape starting from a complete top-down view. Now, what we're going to do is to try another shape, but this time I want to change our view to, so we're going to change it from parallel projection now, and now we're going to change to perspective, and that will give us a kind of perspective view. So when we angle here, we can clearly see that we are in perspective now. And this time let us try something a bit more complex. So I'm going to sketch the letter E. Now to do that, I'm going to start at a random position, just like before. And I'm going to try to keep these lines parallel. Remember, you know that it's parallel based on the color. Now notice now that I'm drawing in 3D, full 3D, instead of a top view. So now you need to keep an eye on what direction you're drawing, because if I'm going upward on the z-axis, notice I'm getting a blue line. And if I'm going across, notice I'm getting a green line. So these lines become important, especially when you're drawing in 3D. So I'm going to go up on the y-axis now. And when it goes here, I know that this line is perpendicular. But of course, perspective can kind of trick us. So notice how this green line here, well, this line is actually parallel. If you take a closer look at this, in perspective, this line is actually parallel to this line. But because it's going in a perspective, it's hard to really see that. So this is why these colors become very important, because the green is telling us that, hey, this is parallel to this, even though from a visual standpoint, because of perspective, it doesn't seem parallel. So we're going to go up. Now in cases where this might look a little weird, what you can do is kind of hold the middle mouse button to orbit your view. There we go. We're going to go across, down, and you know, this is supposed to be fairly easy. What I'm doing is sketching, so we're not going by real precise measurements, we're just kind of eyeballing it. There we go. Okay, great. Now this time around, instead of manually drawing each side, now we're going to use another tool, which is called the pull push tool, and that tool is actually located right here. And what the pull push tool will do for us is, if we just kind of click it here, and we notice when you hover over a particular section, it becomes highlighted. So you hover over the E and you left click and hold and push the mouse up, and what it does is extrudes the shape for us. Now this,
all right, so anybody familiar with this tool?
Yes, sir. I've used it before.
Guys?
Yes, sir. I've used it before.
Is my audio okay?
Sir, it's similar to the extreme with them.
Oh no. My audio is not okay. Okay, good. Yes, somebody answered a while ago.
Yes, sir. I was saying I used it before.
Okay, lovely. All right, cool.
This is true on any surface. So for example, if I go back to my original shape here, I could extrude this higher or lower. I could extrude the base higher or lower. And this is all using that push-pull tool. All right. So far we have used the push-pull tool, and we have used the selection tool. We know that the selection tool allows us to select different objects, and the push-pull tool allows us to extrude an object. We have also used the pencil tool, and the pencil tool we have used to actually create shapes. All right, great. Now, a further breakdown of what these tools do are found on the handout itself. So if you go to the handout, you'll notice that there's a short description for each of these tools here. So in case you don't quite remember what they do, you can always refer to this. All right. So now that we've kind of gotten the hang of this, we are going to now explore how we can do this, but now using measurements, as what we've been doing so far is kind of a freehand 3D modeling, which is what SketchUp is great at. To be instantly able to pull or push different objects is really awesome, because if it was a building, you would be able to explore like different ways of doing something just by simply pulling and pushing. It's a great tool for doing massing, and it's also good for doing accurate massing as well, which we will see now. Now to get going, what I want us to do is go to File and go to let's go to New from Template, and we are going to choose the architectural millimeters template. That's here. And this is asking if we want to save. I'm going to say no, because we don't need to save those shapes. Alright, great. So now you're in the architectural millimeters template. Now, just as before, we're going to ensure that we have our large tool set open, which we can do from View, Toolbars, and Enable Large Tool Set. And we want to minimize our default tray. So if you have this tray open, you're going to just click the little auto hide, or you can actually close it. Doesn't really matter, because we want to get maximum screen real estate. Now what we're going to do is tackle this shape first. So we're going to have this over here, and let's have SketchUp over here. Now there are some measurements that you can see clearly that is on this drawing, but there are some measurements that are also missing. So we are going to combine drawing accurately with measurements along with sketching, which we have just tested a while ago. Alright, so now when we open a new SketchUp, and notice that before we have selected the architectural millimeter template. Now, if just in case some of us might not have selected the right units, we can additionally change the units by going to Window, Model Info, and then you will see units right here, and we can actually change the units. And my unit is currently set to millimeters and decimals, and it is set to display like that. So that is how I know my units. However, because I have selected the template, those were already set up for me. If you selected the incorrect template, you can just set it up in here. You can also change these measurements at any time during your drawing, and it will automatically adapt. Your drawing will not be out of scale. Alright, so I'm going to close that. Now to get going here, first thing I want to do is remove our reference object. So I'm going to just click it. Notice when I click it, you see this blue highlight comes around it. So this highlight here is known as a component. Now, how do I know it's a component? Well, there is actually information on the objects that you select, and that information is found on our default tray. Remember, that was the tray that we minimized over here for me. So if I maximize that default tray and I pin it, let's pin it there. Notice that any object I select, so I select this object, and it tells me some information about it. So it tells me that it is a component, it has a definition, kind of like a name, and that it is untagged here. There's also some options here that you can do to turn it off and lock or unlock it and so forth. So that is where I would get model information. Now we don't need this now, so I'm just going to close that out, and we definitely don't need this model, so I'm just going to delete it. Now the first thing we need to do is look at some of our dimensions here. So I'm going to actually zoom in here, and this form of modeling, which is called solid modeling, because essentially what we're doing is we're going to create this shape from solids. So when beginning to model, the first thing we want to do is think of it as creating a sketch. And some of us can draw by hand, and if we see an image and we want to replicate that as a sketch, we kind of picture the image in our minds, and then we try to execute that using our hands and drawing the sketch. In this case, it's pretty similar, but instead of using our hands, what we're trying to do is to think about ways that we can construct this Lego block together. So let's look at that up close. One approach that we could take to create this Lego block here, I'll just single it out here. Well, we could draw the base first, so we could draw that, and if we translate this in plan view, it would perhaps look like something like that. Then what we could do is translate these measurements. So these measurements here would be equal to the measurements here and here and so forth. Right? So of course, remember that this is the plan view. Then also notice that there is a height measurement next. So we could use the push-pull tool to push this shape up to this height. So when you are creating a 3D model and you have to construct it, this is the kind of mindset that you need to have. You need to kind of break down your shape into basic forms and try and create those basic forms, then manipulate them to get the details that you want. So let us investigate that. So let us, if we now use this approach, we would first need to draw this base here. Now it is 8 millimeters and it is a square, so it should work out to 8 by 8 millimeters. Now, how do you know what is 8 millimeters? Now, this is where things might get a little tricky, because 8 millimeters is actually quite small in comparison to that model that we had. So the first thing we could do is we could get our pencil tool. Then we're going to start from let's get our pencil tool in SketchUp. There we go. We're going to start from the origin here, and we are gonna, well, let's pencil out our plan first. So we want to draw pretty much a shape like that, and then we want to use the push-pull tool to extrude the shape upwards. That is our game plan. So in order to do that, we are gonna first draw that shape. Now we are gonna choose the pencil tool first, then we're gonna click once. Now we're gonna drag along this red line here, and notice when I drag along this red line what happens, right? And if you look closely, you will actually see that when I drag along this line, this value here actually changes, right? So let's look at that again. While I'm dragging this line, you can see the value here that is changing as we go. So right away we can get 8 millimeters there because we could simply just type this in. So let's explore how we do that. Now we can clearly see that, you know, this length is about 300 millimeters. So 8 millimeters is going to be teeny, very tiny. So we need to zoom in some more using the mouse wheel. There we go. And then we're basically operating at a kind of a larger scale. So now, in order to get the 8 millimeters, you're going to hover along the edge of this red line. Then you're going to type 8. Now, when I press the letter 8, notice that that 8 shows up in the bottom panel here. And that is the 8 that I just typed. Now, the line is not 8 just yet. I would need to now press the enter button, so hover along the line, press 8, then enter. Now notice that it has given me a line that is 8 millimeters. Then I need to go across, and I'm going to press 8 again and press enter. Then remember, I'm in perspective, so even though these two lines are parallel, it doesn't appear to be because I'm in perspective. So I'm going to come back across, and this is important that I hover and the line is red. So there we go, and I'm going to hit back here like that. So pretty much what we have here is the base of our model, right? Which is pretty much this section here. So that section there is what we just drew now. So what we need to do is to use the push-pull tool to go up, and that would allow us to get a shape roughly like that. Alright, so let's go. So we're gonna use the push-pull tool, and if you remember where the push-pull tool is, it is this tool right here. Alright, great. So we're gonna grab the push-pull tool, and how tall should we make this? Well, we can see here that the height is 96 millimeters. So we're gonna hover over. Now we need to hover over it for it to be highlighted. Notice how when you hover over it, it becomes highlighted with dots. So you need to make sure that it's highlighted, and you're gonna click once and move the mouse up, and then you're going to type 9.6 percentile. Alright, great. So now we have the basic shape. As a matter of fact, you can start to see the shape come along nicely here. Now we do need to draw this circle in the top, and if we look at the top view, we can see that the diameter of this circle is 5 millimeters. So that would mean that between here and here is 5 millimeters. Now this is where the sketching skills will come in, because we know that the circle is at the center of this box here. We also know the full length of this box here, and if this is at the center, then essentially you would need to subtract 8 from 5, subtract 5 from 8, which you would get 3, and that would mean that each of these distances here is 1.5 and 1.5.
Are you guys following how we got the measurements?
Yes,
Guys?
sir. If it's centered, then it has to be 1.5 from each side to give.
Right. You're going to have to do a similar thing when you're working on the exercise 5. So that's what I just want to make sure that you guys follow the logic, you know?
So this is just from doing the simple math. Now, if we look back at our model that we have here, we know that the circle, this circle here, should land somewhere in the center here. We know that it's going to be in the center of this line here. And we know that these distances here should be 1.5 for each area. So in order to do that, we're going to use another tool in our arsenal, and this time we are going to use the tape measure tool. Now the tape measure tool is located here. That's the tape measure tool, and that tool is primarily used for you to set up reference lines, so you can know where offsets are, centers of things, distances. So we're going to test out that tool now. Right now, to use the tape measure tool, you're going to click on it, and how the tape measure tool works is, in this case, we want to find the center of the shape. Now we could do that by simply drawing some diagonals. So I could draw a diagonal from here to here, and I could draw one from here to there. Now tape measures are reference shapes, reference objects. So this is actually not cutting the actual model. Now, just as a reference, I'm going to undo this. You don't need to follow me with this example here. But if I seek to use the pencil tool to mark out my center, let's say I draw a line here and I draw a line here. Right? And you might say, well, this is doing the same thing as my tape measure. But actually it's not, because what this actually does is split the mesh. So for example, if I should use a push-pull tool now, you will notice that these are actually independent shapes because I've literally split the mesh. Now, so ideally I wouldn't want to split the mesh, because all I really need to do is to find the center so I can put the circle, and I don't want to have to unnecessarily give myself more work by cutting this square just to get the center here. So I'm going to undo that. A better way would be to use the tape tool, and the tape tool will give us an outline, but it will not cut our mesh. So if I go to the push-pull tool, notice that this is very much still a full mesh. Now I've gotten to the center of my object here, and I know that the diameter of this circle is 5 millimeters, so hence the radius would be 2.5. So what I can do now is to get my circle tool, and your circle tool is located here. Okay, so your circle tool is located here. So we're going to click the circle tool, and we're going to put this at the center of these intersecting lines. Notice that it snaps, and we're going to make this radius 2.5. All right, great. So this would represent where this circle is. Now our next step is that this actually has a height of 1.7 meters. So we're going to grab the push-pull tool now and push this up 1.7. All right, so you can kind of see now how it is coming together. Now, of course, there is one major component that we have to consider. This is how the inside of this Lego blocks looks. But obviously, if we look underneath, we can see that this is a solid block. But we need this block to be cut just like this. So it's going to require more sketching, 3D sketching skills in order to figure that out. Now, the first thing we want to get is, what about this hole in the bottom? If I look underneath this now, you can see that I don't have a hole here, but there should be a hole like that. So therefore, you're going to need that distance here. You're going to need the distances here in order to know where to cut this hole. Now, in order to get that, if we look carefully on this sketch, we can actually see that this edge here basically aligns with this line here. So we can actually use that assumption in order to know how wide this is. And we know how wide this is because we know the diameter of the circle. So that means this length would add up to 1.5. So what we're going to do now is we're going to draw this 1.5. Now, to do this, let us try and explore yet another tool. Now, the tool that we're going to use is going to be our offset tool, and our offset tool is located right here. Right? And what the offset tool does, well, it does exactly what it says it does. You know, ideally, I want to offset this entire edge, and I want to offset it inward. So all these 4 lines I want to offset inward so that it gives me an inner edge like that. So in order to do that, we're going to choose the offset tool. Choose that, and we're going to hover over the area that we want to offset, and we're going to click once and move the mouse, and notice that it's actually previewing that offset, but we know that it should be 1.5, and we're going to press enter. There we go. So that gives us the square below. Now we still have a few things that we need to investigate. So what exactly is this height? So we would need this height here. And how could we get that? Now, once again, we're going to rely on our sketching skills, and if we look closely, we can see that this distance here is going to be equal to this distance here. And we know this distance, we know that distance already, because that was here, 1.7. So that's what that distance is. So hence we can assume that this inner part here is also 1.7. And if that is 1.7 and the total height of our box is 9.6, then that would mean that we would need to minus 1.7, and then that would give us the length here. And of course that would give us a total of 7.9. So we know that we need to extrude this inner face upward 7.9 millimeters. So to do that, we are going to go back for our push-pull tool, but instead of pushing out, we want to be pushing upward, and we know that that upward push should be 7.9. all right, so now that is the correct length. Now we do need to figure out what is the dimension here of this circle. And once yet again, we're going to be turning to our 3D sketching skills, and these skills are things that anybody in the design field should know. We should all have an idea of proportions, right? So now we can see that this distance here is the same as this distance here. So we know that this has an offset of 1.5 and 1.5 on this side, so that is a total of 3. Then now we know we would need to subtract that from the total dimension of the circle, and the total dimension of that circle is 5 millimeters. So hence 3 from 5, that would leave 2. So that would mean that what would be left within here is actually a 2 millimeter diameter after we take these out of it. So that means that the diameter of this space is 2. So what we need to do is do the same thing again. We need to draw a circle inside here, and then we basically need to push that upward so that we can get the space inside this space here. So to do that, we are going to go for our tape tool again, and we're going to just find the center of this space. We're going to use the circle tool and go here, and we know that this should be 2 millimeters. All right, actually no, 2 millimeters is the diameter, so the radius would actually be 1 millimeter. There we go. So now that is, this space here is equal to that space there, and we did that with simple proportion and math. Now this space needs to be pushed upwards to cut out this space here. So how high upwards does it need to go? Well, we need to go to here, and we can see that this is aligned with that area there. So henceforth it's the same depth as this, as the top here, and that distance was 1.7. So we're going to grab our push-pull tool, and we're going to go up 1.7. all right, now basically we have our shape there. However, we do have one element that is left, and you can clearly see that the word Lego is written on the top here. So what we would need to do is we would need to go back to our large tool set and use the 3D text tool. So to use that, we just click it, and just wait for a while, and this will pop up. So we're going to type the word L-E-G-O, Lego, and I believe it's full caps. Then we want to choose a font. I'm going to use my font. Let's just use a font that everybody has. So we're going to use Arial, and we're going to make it Arial Italic. There we go. And maybe we could do italic and bold so it's big. So I'm going to choose OK. Now this text is kind of big here. So basically it's asking us where we want to put it. So we can just really plop it down anywhere. And then we can start to resize this now. So we're going to click. We're going to highlight it. And then we're going to go to the scale tool. Now the scale tool is yet another new tool, and that tool is located here.
Wait,
Once
sir,
you click
I
the
missed
scale
where
tool, you're
the,
going to see these green boxes around
where
it.
the word icon is. Where is it?
It's right here in the large tool set.
Oh,
It's
it's the
the
one.
letter A.
Oh, because I had pressed the one above it, I'm just like, this doesn't look right.
No,
Okay.
that one is for annotation.
Oh, okay. Thank you, sir.
So essentially what you want to do is grab one of these corners here and make it just click it once and then make it smaller. To zoom in, we're going to click it once, make it smaller. And let's try and do that one more time. All right. Now we're going to use the move tool, and the move tool is located here. And how the move tool works is you basically need to choose somewhere to grab the shape. So I'm going to grab the shape right here, and I'm going to click once. And then notice that it's basically stuck. So I'm going to zoom out, zoom in, and hover over maybe just somewhere random here like that. Then I don't want to go back for my scale tool and rescale that. There we go. Then go back for my move tool and grab it from one corner and kind of just put it somewhere. All right. Now if you're having trouble moving this in 3D, what you can actually do is go to camera and just switch to the top view. Then you can try and move this around, and that should be way easier. Let's try grabbing it somewhere outside. And let's kind of... That may not work out so good. Let's try. All right. Now, in order to test if our Lego is correctly done, there's another tool that I want to introduce to you guys, and that is called the section tool. And to do the section tool, you're gonna, here is that tool here. We're gonna click on it, and what it actually does is create this section box here. So I'm gonna stick it right here, and it's gonna ask you to name it. I'm just gonna leave it at the default name. And then what you want to do is use the move tool and just move this section. So I'm going to click to hold it and then move the section. And when you look, your section should be pretty much similar to this. So this is how you know that what you have done is accurate to the paper. Okay, so that is the basic premise of using SketchUp to create this shape. Now what I want you guys to do now is to complete the exercise for today, which is drawing this shape, and all the dimensions are there. So you're gonna draw this shape, then use the section tool to cut the model, right? And you're gonna submit this model for me to check, and that is what you will submit for your exercise. Now you are not to submit this that we did as an example, but you're going to submit this version.
All right, guys. So that is what we're going to be doing in class today. Now, there's one final part that you guys will be learning, and that is going to be SketchUp layout. Has anybody ever heard of SketchUp layout? Anybody?
No, sir.
Ah. And it's such a very weird thing because I used to learn SketchUp when I was in school. It was owned by Google at the time. And I don't think we've ever taught it. And guys, do you know how it can save your life? This SketchUp layout tool? You have no idea. So I thought to myself, how is it that you guys are not learning to use SketchUp layout? So that is the new thing that you guys are going to have the benefit of learning. And it's not anything major. SketchUp layout is simply, how do I put my drawings, my model, whatever I created on a sheet so I can print it. Normally when we do things in SketchUp, we save it as an image, and then sometimes we put it in Illustrator or InDesign, or we just throw it on a Word document. But SketchUp actually has its own layout tool that is pretty powerful. And we're going to be using the layout tool to do this. So let's take a look at the layout tool. Sorry guys, I'm just waiting on the internet. Okay. I think it has caught up with me. Okay, so now that we have our model cut as a section, we're going to look at how we can place this model into layouts where we can generate multiple views. Now, in order to do this, we're going to create various scenarios here. So I'm going to delete this section line. And what we're going to do is save different scenes first. So let's say that this is a particular scene that I would like. I'm going to go to styles because I want to set how I want my model to look, and I don't want to have it in this gray background. So when I go to the default tree and go to styles, I'm going to go to default styles, and if I just make this a little bigger here, I'm going to choose the hidden line style. or I will choose this style here, which is the construction documentation style. I think that one is a good style to use. All right. Now that I've selected the style I want to have, I'm going to now go to themes, and I'm going to click this little plus here, and this will save this as scene 1. Now, so what happened is that I think I'm actually blocking that little area here. So where I went to was scenes, and then this was a little plus that I clicked here. All right, you got that, guys?
Yes, sir.
And when I click the little plus, it saved it as scene 1. I want to take another view like this where I can see underneath my model. And then I'm going to save this as another scene. So I'm going to hit that little plus again, like that. And then for my third shot, I want to have a section view. So I'm going to go back and put back my section line by clicking the section tool here. Look at that. Then I'm going to go to my move tool and just move this roughly about to the center of here. I'll zoom in a little bit. And then this will become my third scene. So now I'm going to click the plus button again. And I'm going to choose create scene. So notice I have 3 scenes. And up the top here, you will see I have 1, 2, and 3. So if I go back to 1, that's what it's like. And if I go back to scene 2, this is a view from underneath. And scene 3 is a section view. Now, I could do one more scene. So what I'm going to do is, so now I want to create my 4th view. So what I'm actually going to do is I'm going to deactivate this section, and then I'm going to go to view and to go to camera, make sure that I'm on parallel projection. I'm going to standard views and go to top, and then I'm going to hit the plus button again, and now it will save it as scene 4. So now I have 1, 2, 3, 4. And those are my views. So next, what I want to do, I want to go to file and go to send to layout.
Wait, sir, I didn't get.
It's going to ask me if I want to layout is for the
I
4th.
didn't get the 4th one, sir.
For the 4th one, I just did a top view.
Oh, well, how did you deactivate the section? Is that
that's a good question. Yes, right click and choose the activate section, and it will deactivate it.
Oh,
Right? So if I have a section that is currently active, I can right click it and choose turn off active cut.
okay.
You can only have one active cut at a time. So that's an important thing to note. So you can, basically, you would save different scenes with different active cut sections if you wanted multiple cuts. You understand?
Yes, sir.
Right. And then what we're going to do is we go to file and we go to send to layout, and it will ask us to save the file. And this is where we are now. This is a kind of a sister program to the SketchUp program. And what it does, it uses the main model and allow you to generate multiple layouts using the 3D model that you just created. So for this purpose, I'm going to just choose a letter landscape. And notice how it gave me this view here. Now I'm going to put this view. I can click on it and notice I have these 4 corners here. So I can crop the view if I want. I can make it smaller. I can size it smaller like that. I can move it around and put it anywhere on my sheet. Now, notice there are also some icons up here. So this is like a 2D only view, kind of like using Photoshop or maybe in this Illustrator, where I could just use my pencil tool and draw random lines, or I could grab my text tool and start to type in a text box, and I'm able to move that text box around just as how I would normally move a text box around in any typical application. Now, there are some other shapes that are up here. For example, I have dimensions and annotations and labeling. But more importantly, over here on our default tree, if I minimize all of these, you will notice that these are all different properties based on the items that we have selected on our sheet here. So for example, if this text that I just placed here, if I clicked on it, then notice that under text style, it would give me things like justify left, justify right. I can change the size of the text, whether it's bold. I'll just put this down in this left corner right here. Now, I can also select the drawing I have here, and there's a bunch of different settings that I can change with this model. Now, keep in mind that this is simply a window into the 3D model you just created, right? So I've actually taken a snapshot of the SketchUp model here, and I've taken that snapshot into this new program called Layout. And in this new program, I can now apply additional options to it. So with this model selected, I can, for example, go to SketchUp model. And if I expand this down, you will notice that there are different subcategories. So for example, if you look here, these are all the views that I saved out. So scene 1, scene 2, scene 3, and scene 4. So I can manipulate them from here. There are a couple other options here, but the one that we're going to care most about is going to be our scale, right? So right now, we're not using any particular scale, and we are using our orthographic view. Now, we also have some other additional effects, such as shadows and styles, but we're not going to change those settings because we already set the style from inside our SketchUp model. So I'm going to make this a little larger. Then what I'm going to do is right click, and I'm going to copy and paste. And then I'm going to move the copy. So notice now I have two different models, but they're both referencing the same SketchUp model. So for example, I can click on this view now, and I can change this to scene 1. So now I have these two scenes, but they're linked to the same model, which is pretty cool. Now, same way, I can select both of these, and I can copy them, paste them again, move them down. So now I have 4 different models, and I can make them all different scenes. Pretty cool, right, guys?
Yes, sir.
So to Javel. Javel, don't think it's pretty cool too? Javel?
Yes, sir. Yes, sir.
All right. Now, the great thing about this is that they're all linking to the very same model. So for example, if I go back to my original SketchUp file here, and I decided to edit this model. So in this case, I'm going to put a little shape right at the corner of this model. I'm going to just extrude that upward. So now I have this additional shape here. Now what I'm going to do is hit save, and I'm going to go back over to the layout application. Now notice you don't see that change yet. And this is because I need to select the actual model and choose this reload button. Now notice when I do that, everything becomes updated. And now you can see the change that I just made in SketchUp. So this retains a live link to the SketchUp model, right? And this is excellent because now we can move back and forth between SketchUp. Now, some additional things you can do is you can dimension from this view as well. So if I hit the dimension tool here, I can actually draw dimensions in plan. I can even draw dimensions in 3D views. Which is pretty cool. I can also choose labels. Now, the one thing to keep in mind is that these labels are not a part of the original model. So what does that mean? Well, if I go back into my model here, and let's just say I change the length of my model. Now, if I hit save, and I go back over here, and under SketchUp model, I chose to reload the model, then notice that everything changes. And in this case, the length automatically changed as well. Now, it is very possible that these linkages can be broken because this is simply a 2D overlay that is detecting the 3D corner in this SketchUp file. So that means if we did significant changes to this shape, then we might lose this dimension and we have to now redraw it. Now we can also undo, so I can undo that change and I can save again. And I can come back over here and update the model again. So just like how we added a label here, we can also add some labels here. So we could say plan. We could say 3D view 1. Now, additionally, I can also copy labels. So I can Control C or copy, and Control V. And I can move those labels around. And then I can rename this. And I think I will call this 3D section. Now, there are a host of other things that we can do in this layout view. So for example, we can put different objects on different layers. We can also add additional pages to our model, and we can change things like dimension style. Like if we wanted this dimension to be displayed a little differently, we can change our dimension style and other things. So in a nutshell, this is what the layout view is. And now when we have finished doing this layout, we can now save this file. Now SketchUp will save as a layout file format. So it's a .layout file. And this file is always referencing the original 3D model. So it's a good idea to always save this in the same folder as the model file. I have to call this layout sample. Now we can go ahead and export this as a PDF. There we go. And now we have a PDF of our layout. Now, one thing to note, while you are working in layout view, you might notice that the quality looks a little bit rough. And that's because layout is just giving you a preview that allows your viewport to run really fast. But when you actually export your file, you notice here that everything is nice and sharp. Okay, great. So that was a quick rundown of how to use the layout view in SketchUp.
Sir, I have a quick question. How can I add more? I missed part where you add more
more views.
Yeah, more views, yes.
I just copied them. So you just copy an existing view to get a new view. All right. Now, layout is especially great, guys. If you have, I guess you can already think of different ways you can use it. Not only can you put the 3D model in layout, but you can also add things like photographs. You can import like PDFs, DWGs, and add them onto your sheet, just like if you were doing it in Photoshop or Illustrator. The only difference is that layout keeps an active link to the model, which is excellent because you get to edit the model and update the layout. All right. So, what you're doing for me in this class activity is to do that single Lego block all the way to the layout view. All right, guys? Which I think was pretty straightforward. You guys can remember how to do that? Guys?
So we're here.
Okay. So you're gonna do that single Lego block for me. And we're gonna submit it. Then you're going to, on your own, you're going to tackle the other exercise. If you want, I know you have another class after this, and this is pretty much the class time. So when you come in the other class, we're going to be working on the larger Lego block together. All right, guys?
Yes, sir.
All right. Okay, guys, I hope that SketchUp seems very excited for you to now learn. And I'll see you later in the working session.
Okay, sir. Bye.
All right, sir, bye.